this computer. And so basically, sorry for the inconvenience again, but I think we are all settled right now. And so basically, in doing statistic problem, it's critical to understand the sample space first. And you have to, even at each step, for example, if you dissect this problem from a total count. So the first way is a total count, And the second way is multi-step count. So this is a multi-step. A multi-step count, basically, you dissect problem into the multiple step, and each step has a reduced length sample space. For example, this is a couple. In the first, it's a couple sample space, and this one, it is a single. It's a two single sample space. So this step is a single. This step is another single, and because it's a compound event, you compound event by multiplying their probability. So that's the way to solve this type of a problem. And so basically, either way you will be able to do it right. Especially in the test, I will really recommend you do the problem with one method and be aware of another method and double check the problem with another method. So you have a higher chance of, do it right. Otherwise, if you repeat the same method, doing a double check, you won't discover the issue. So let's do this example. What is the probability of selecting two A's from a standard shuffle deck without replacement? And so first we have to understand what is a deck of cards. A deck of cards basically is 52 cards made up of 4 suits. So this is the spade and the diamond and the heart and the club. So each have 13 cards going from ace to all the way to 10, then jack, queen, and a king. So given all those cards, it's asking the probability of selecting two aces without replacement. Without replacement means that you are not putting back the first ace. The second time you choose the card, there's one less total card, also one less ace. So let's do it in two different ways. The first way is that let's do a total count. Total count basically, picking two cards, basically you are looking at sample space of two cards. It's a couple, for example, made up of all the letter sequence, like, for example, this is club ace. And for example, this is heart queen. And then I can pick another sample. For example, this is the diamond one and heart 3. Diamond 1 is basically, let's say that diamond 7. Diamond 7. Diamond 1 is basically another ace. So this and we count all the possible ways. Basically, is 50 cards to pick 2. So basically, you can say, and it's ordered. If you do it ordered way, basically it's 52 permute 2. Then that's the sample space. Then possibility of selecting two ace. So basically the first ace, the favorable case is basically it's still a double. And for example, that's club ace and diamond ace. And because we are doing it a like ordered set, so basically the sequence matters. And like diamond ace and the club ace will be a different element. So basically, but those you can never have club ace and club ace because is without replacement, it's impossible to have two same card. So basically, if we do it this way, basically the top number basically it's 4 permute 2. And so 4 multiply 3 and 52 multiply 51. So that is using like 2. And we can also use the compounding event. Compounding event is that what's the chance of picking the first card heart? Not heart, first card ace. The first card basically, so this is like holistic way viewing it, then this will be just 2 steps. The first step will be one pick, and you have 2 cards, or you have a deck of cards, so it's a single. So you view it as a single. The sample space is just a whole suite of cards. Each card look like this. So basically, it's a single, and each single just a single card. And you have 52 of those. And the way to pay favorable pick an ace. So the favorable set is basically is like heart ace and club ace and diamond ace, something like that, something along the line. You have 4 of those. That's event 1. Event 2, basically, it actually will reduce the total card count. So the sample space in the event to pick the second card is 51, and it's going to be 3. So you actually end with the exact same. So this is the second way. So this is the probability. This is using probability. Actually, you see that, even the multiplication method is identical with those 2 methods. This is just counting the end result counting. And this one is that compound whole event into 2 independent event. Oh, I'm not sharing, sorry. That's so sad. Yeah. Right now I should be sharing screen, is that right? Did you see my screen? Yeah. Okay, so let me, since I didn't share my screen, I'm going to, explain this a little bit more again. So basically the probability of selecting 2 ace from a standard shuffled card without replacement, we view this whole deck of cards, and there are 52 cards in this selection. And if we just do the counting method, we know that sample space is a 2 card. So it's a couple. Basically, it's a 2 element ordered sequence. And there are 52 permute 2 total ways of arrange those couple. Then favorable count, we have 4 ace card, and we have 4 permute 2 ways. So that is our probability. It's going to be identical with the compounding probability event. If you compound probability event, the first event is viewing the event as a single. It has total of 52 cards to pick from, and you have 4 cards favorable in your favor to choose from. Then once you do the first one, you have fewer chance on the second one. So that's the way that doing this. Then let's do the one more, and we will conclude this class. And then what is the probability of selecting 3 blocks of the same color without replacement? And so basically, it's still in the so we are still talking about 3 red block and 4 green block. We view it as a separated way: green 1, green 2, and green 3, and green 4. And then we have red 1, red 2, red 3. So we have altogether we have 7 block. And the what's the probability of 3 block of the same color without replacement? So the only way to do it is that we can select either 3 green or 3 red. So basically, if we view the whole event as a triple, and the total sample space is actually 7 multiply 6 multiply 5. Because once you pick the first block, the remaining choice will be 1 less. So that's why it's descending. It's also called 7 permute 3. Then, so this is do this problem as holistic way, just trying to see how many ways to do it by counting the end result counting. So this is the first method, is end result counting. End result counting. And then to choose 3 green block, because I have 4 block to choose from, the first choose, I can pick 4 and 3 and 2. So that's how many ways to choose the green block. Then that's all green. Then all red, I can 3 and 2 and 1. So adding together, that's going to be how many ways you will be able to do without replacement. And so those event, green and the red, those are totally exclusive ones. So that's why you are able to add. And you can also view it as a probability event. So this is count end result. If we count just break into the event, compounding event. So basically, there are 2 ways to choose all red or green. So all red, this is compounding. Compounding event, if we choose just green, and the way to choose the first block green is 7 false, because I have 4 green block. Then after choosing the first green block, the probability, so this event is a single event. So the sample space is a 1, it's a green 1 all the way to red 3. This is, so you just imagine you doing this problem by tuple concept. So this single event 4 sevens, then it's going to be 3 6, then it's going to be multiply 2 fifths. So that's the probability, that's the compound probability of choosing a green. Then you have to add the probability of choosing a red. So to choose red the first time, it's 3/7 multiply 2/6 multiply 1/5. So adding it together, that's going to work. I think we finished today's class, and sorry for the inconvenience, and thank you so much. Have a nice one.